Keisha. I keep a journal filled with the data I'm collecting about the plants in my garden. I want to organize it all. How can I organize the data? I know. I will make a line plot. A line plot uses marks above a number line to record each piece of data. The marks could be X's or dots. Either is okay. A line plot is also called a dot plot. So I measured the diameter in inches of some grape tomatoes picked in my garden. I have 1/2, 5/8, 1/2, 1/2, 3/8, 1/2, 3/8, 3/8, 3/4, and 1/2. Make a line plot of the data. To get started with a line plot, I need to determine which numbers to put on my number line. I see that I have fractions with different denominators. To make it easier, I am going to rewrite all the fractions as equivalent fractions with a common denominator. The denominators are 2, 4, and 8, so the least common denominator, or LCD, is 8. Now I will write each fraction as an equivalent fraction with a denominator of 8. 1/2 is equal to 4/8, which I found by multiplying the numerator and denominator by 4. 5/8 stays the same because it already has a denominator of 8. Then I have 2 more 4/8 in my data set, and 3/8 stays the same. I have another 4/8 and 2 more 3/8. 3/4 becomes 6/8. Finally, I have another 4/8. Now I can make my line plot. I am going to mark my number line from 0 to 1 using 1/8 inch increments. I don't need any values greater than 1 because all the diameters are less than 1 inch. Now I am going to place a dot above each number on the number line for the diameter of the grapes. I have 4/8, 5/8, 4/8, 4/8, 3/8, 4/8, 3/8, 3/8, 6/8, and finally 4/8. Line plots can be used to answer questions about data. I have a lot of questions about my tomatoes. For one thing, what is the difference between the greatest value and the least value in the data set? The greatest value is 6/8 and the smallest value is 3/8. Difference means to subtract, so I need to subtract 6/8 minus 3/8. The denominators are the same, so I can subtract the numerators and keep the denominator. 6 minus 3 is 3 over the denominator of 8. The difference is 3/8. That means that the difference between the diameter of the smallest tomato and the largest tomato is 3/8 of an inch. How many values are below 1/2? Remember that 4/8 is equal to 1/2. Below 1/2 would mean the values to the left of 4/8. I know values decrease or get lower as you move to the left on a number line. The only value that has dots to the left of 1/2 is 3/8. There are 3 dots above 3/8, so there are 3 values below 1/2. That means 3 tomatoes have diameters less than 1/2 of an inch. My final question is, what is the average of the data set's values? To find the average, I need to add all the data values and divide by the number of values. In this case, there are 10 measurements. I will add 4/8 plus 5/8 plus 4/8 plus 4/8 plus 3/8 plus 4/8 plus 3/8 plus 3/8 plus 6/8 plus 4/8 equals 40 over 8. 40 over 8 reduces to 5 over 1, or just 5 inches. To finish calculating the average, I need to divide the total, 5, by 10. I can also write that as the fraction 5 over 10. That simplifies to 1/2 inch. The average of the data set's values is 1/2 inch. Making a line plot will make organizing the data about my garden plants much easier. I had better get started. Now I have a great visual representation of the data about my tomatoes. There are lots of other questions I could answer about my tomatoes, such as how many tomatoes are a 1/2 inch in diameter?